Hi, welcome to lesson 3 on KiCad for beginners. Today we're going to be importing our netlist into PcbNew. We're going to be arranging our components. So with KiCad open, we can open up a PcbNew, and this opens us onto a blank page. So the first step is to import our netlist, read current netlist, and this imports all of our parts from the schematic. All the components are joined by these grey lines called the rat's nest, and this shows which pin connects to what pin. So the first thing I want to start arranging is these pots, as these are the control surfaces for the user. So their position is going to be dictated by our graphics, the case, and how we want people to interact with this device. Now this view at the moment is looking at the component side of the board, and these pots will go on the reverse side of the board to be mounted into the front panel. So to make sure I'm looking at this how the end user will be looking at this, I'm going to flip the board view. So now we can arrange it as if we're looking at it like that. Don't have to get them in the exact position, just in the general order we want. So the next stage is to arrange all these parts in functional blocks. And if we do this while following the schematic as closely as we can, we'll find that by the time we've done this, a lot of this rat's nest of connections will be a lot neater, so it will take a lot less effort for us to run all the wires once we've done that. So I'm going to open up the schematic again. And a great feature of this software package is when I've got the schematic and the PCB layout open, if I click a part on the PCB, it will snap to that component on the schematic. And likewise, if I pick a part on the schematic and click it, it will jump right to that part and highlight it on our PCB. I'm going to flip this view back now. So we're now looking back at the component side of the board, and I'm going to start now just by arranging these components into these functional blocks that we've already highlighted. So first gain stage, second gain stage, third gain stage, our tone stack and the fourth gain stage will all be in separate little blocks. So like a schema, you can, when you're hovered over a component, press M and it will move it around, and if you hover over and press R, it will rotate the part. So while I'm doing this, it may actually be easier to turn the netlist off. You can use this to turn the netlist on and off. So these pads we added here will short out this part of the circuit. So this will let us put a daughter board in here to replace these two diodes, which then means we could put a daughter board with 5 or 6 clipping options on it. It gives us a lot of choice because we can put one in there, and I've done the same here. So it'll give us a lot of different choices over clipping diodes. I've done the same thing for the tone stack here. So again, we can just leave all of these parts out of the circuit and put in a daughter board. And I've got a bit of an idea. I don't know if it'll work, but I'm thinking of a little header and maybe a bit of the board that we can literally pop out of the rest of the circuit and replace it with another board with the same shape but with a different tone stack in it, which would be a cool little you know, hot swappable tone stack. Be an interesting little change to make to this if we can pull it off. Okay, so we have our rough functional blocks. We've got gain stage 1, we've got gain stage 2, gain stage 3, and this last gain stage 4. Where's that cut from? oh, that just goes after this high-low input switch before the first gain stage. So that's going to join that switch through there. So we can see our signal flow now is a lot more logical. Now, if we turn on our rat's nest, it doesn't look as bad as it did before. We can start to make sense of that. Now, I've noticed a problem. On our board, pin 1 is labelled up E, and pin 3 is labelled up as collector. Now, on here, I've got pin 3 is emitter, and pin C is the collector, which seems wrong. So my best option really with this is to get the transistor out that I'm expecting to use and test the pin out on it to see which way round the pins go, and then we can edit the part and make the pins match the schematic. So here I have a DCA 55 from Atlas Peak, really good little tool. Got the transistors I'll probably use, BC550Cs, and I've inserted that into my tester the same way it's orientated on the computer screen, and we can press test. NPN silicon transistor, scroll through. So I've got RGB from the top down, collector, base, emitter. So this is backwards to the one we've got on the schematic. So if I press Control E, brings up edit part, and then we just want to move these pins around like that. Save that, and it'll go save footprint as, and I might give this a specific name, BC550 in transistors. Now this footprint that's here hasn't changed. The one we've edited is the saved model, so we need to update this footprint. Update footprint from library, and we can do update footprints with matching value, BC550, and it does seem to have made 4 changes to our board, so that's a good sign. Apply, close. That isn't correct. Pins are right, but the footprint is still backwards, so that way around. So it's literally the graphic is the wrong way around. So if I go Control E, the pins weren't wrong, just the labels were wrong. File, save, transistors as BC550, close that, and then E-edit, update footprint from library. This time we're not changing it because it's saved as the same with the same name, so it should just be update footprints with matching value, BC550, and this should change all 4 to be correct now. Apply, close. So we now have pin 3 collector, pin 1 emitter. If we use our Atlas DCA to test it, this is saying red collector, green base and blue emitter. So it matches what we have on the PCB. That is now correct. Okay, the next thing we're going to do, I was saying in the previous video, we're going to copy this part, we're going to duplicate this part and put in the SMD footprint as well. So if you want to use SMD transistors, we can just drop them into the circuit and leave the through-hole ones out. So if you just hover over the component and press Control D, it duplicates the part. We can then go Edit, change footprint, and we can select SMD footprint here. And this time we only want to change this footprint, because if we try and change every footprint, it'll change these ones as well. We don't want to do that. So just change that one, apply. Now this probably won't be a BC550. In fact, in my SMD folder, bipolar transistors, we have 3 904s or 5088s. I would probably use 5088s in this one. So what I can do, if we go on Google quickly, T5088, pin out. Bass is pin 1, emitter, I think the numbers are back to front on here, but it matches the it matches that schematic. Emitter is pin 1, bass pin 2, collector pin 3. So that is correct, that's fine. So now we have a choice of through-hole or SMD parts when we are picking our transistors. So I'm going to do the same with all these other stages, and I'm going to do the same with the transistors, make sure they're correct, and add in the SMD parts. So when we're arranging these parts like this, I'm trying to ignore these ground nets as much as possible, because if the entire back of the board is a ground plane, this ground can kind of connect anywhere. So I always want to keep the other wire as short as I can, because there's only 2 points that can connect to, and if you move this around you can see the net will jump to other potential places that ground can join. But it'll always stay attached to one of these 2 pins, because it's the only pins it can attach to. So I'm always trying to minimise the length of whatever pin isn't a ground or a power supply, power line. What I'm going to do is change these 2 pins here, tone pad 1 and tone pad 2, for another one of these 4-way headers, quick connects, because then I can put the ground connection on that header and volts as well. So if we want to make a PCB where we can swap this, and I don't know if this is going to work, I'm just seeing if we can do it. If we want to make it so we can kind of hot swap this bit out, and we could maybe put an LED on there, and then we've got volts and we've got ground ready to connect it all up. So in order to do that, I'm going to remove these ground pins, because we don't want these grounds connected to any other grounds in here except through the header we're going to add. So I have, what I'm going to do is a global label, and I'm going to call this BGND, B ground. So I can now use this label on another one of these headers, and by doing this we're going to break the previous connection to ground, which will let us treat this whole bit of the circuit as a kind of external block. I'm going to have to move that there, and then move that there. So our input will go here, and I'll delete that wire, and our output will go to here. We've already connected up the grounds. This 9-volt power here, at the moment I'm just going to bring it to another little pin, and the reason for that is so it has a connection, something that we can join something to later, but I'm not actually going to attach it to anything at this stage. So it just gives us an option for later when we come to mod it. It could be useful. I always find it's easier to include an extra pin rather than wish you'd included it later. And I'm just going to call this plus 9-volt. So that will just be a 9-volt pin on this little, which is now looking like it's going to be a daughter board. But we're not going to connect that label to it, because this, if we want to be able to cut this bit of the board out separately, we don't want any traces actually joined to it. We're going to have to put in another header attached to these bits of the circuit that will join to it. So I'm going to create another one of these board quick connects by copying. So I could put this anywhere, but just to make it obvious, and we'll follow the labels here. So although this is going to be an out from this circuit, and this is the into this circuit, I'll follow these labels. So we've got our output here goes into this circuit. We've got 9 volts. We'll go to 9 volts. Our grounds will connect together, and our outputs will go to the output. So all we need to do now is add the wires and add this 9 volt flag here, and we'll also add the ground flag. So now this tone section of the circuit is a removable daughter board rather than a permanent part of the circuit. Unfortunately now this does not match our schematic, so I'm going to save it. You can generate a netlist again, or you can update PCB from schematic. Now this will probably undo a fair few changes we've made. It may put these back to the old footprints. Usually okay if you've not made too many changes. So because we haven't annotated these parts, it's just asking us to re-annotate them. So we can go annotate, keep existing annotation, use first free number after, let's go 30 so we know everything after 30 is an addition we've made, and we can go annotate. Yeah, so it's going to change a lot of these parts back, but that's fine. Update PCB and close. It's added in a few extra components, most of which we were expecting, and it's reset these. Now edit, let's just change these back to BC550 and make sure they are correct. Apply, change footprints with the identifier, apply. So I think they are, yeah, you can see here it did change them. Collector base emitter, that one's correct, these ones aren't, but that's fine. Hopefully that will be the same. Collect base emitter, yep, collect base emitter, collector base emitter. So that's fine. We've just got to change these back to the SMD parts. Change footprints with the identifier TO92- to that, and close. And now this should all be back to how it was. But now this part of the circuit here, so if we ignore this bit, if we move this around, we should see that this now has no connections to anything else. He says, what's that connection there to? So why is that connected to there? That's a mistake. I don't know why that's doing that. So what I'm going to do is we'll do it properly. We'll go CV PCB, and we'll just double check. We can change these while we're here. So these should be transistors. I'll just change them to those ones. Everything else should be as is. Apply save schematic, OK. Netlist, we can generate netlist, and we'll just overwrite the one we did before. And now if we read current netlist, 4 warnings. So it's just going to delete these SMD parts we added. Why is that still connected to that? Ah, okay, for some reason. Okay, there we go, that's what the problem is. For some reason, when I copied this part, it seems to have copied, it's made an exact copy of that part rather than calling it a new part. Don't know why it's done that. So if I call that board quick connect 2, because I don't think there's another one, so board quick connect 1, board quick connect 2, I can now generate netlist, overwrite that netlist. So now if I re-import my netlist, let's see if that has fixed that issue. That does seem to have fixed that issue. Right, there we go. Okay, we're back to where we were. All these footprints now at least are correct. We just got to change them back to SMD, and we now have a completely separate daughter board with our tone stack on them. So the idea is we can put these two parts next to each other and we can do a board cutout, and now it should go in to in, plus to plus, negative to negative, and out to out. So if we join these two up, it will be in circuit, so we can now put a little header pin in here, and we may even be able to, if we're clever, make a little plug-in tone section, which then means we can later copy this board and just do different versions of this. Okay, not seen that before. I'm going to save this before I go much further. Oh god, what's it doing? That was a little bit painful, but at the end of the day we seem to be back to where we were, but our board now is much more useful because of it, and could be a nice little feature to have a plug-in tone stack. Our functional blocks are back to where we were, but we have this removable tone stack, so that's a good point now to work from.